All right. Hello, everybody. Welcome to Ms. Adkins, 7th grade math. We're working in our Module 1, Lesson 1 today. In your Eureka Math Workbook, that is page 1. It tells us page 1. So it's S.1 in your Module 1 Eureka Workbook. Again, this is North Parkway Middle School 7th grade math class. I am recording for this week. You'll have other teachers recording on the other days, possibly. All right, so today you will need a pencil, your calculator we provided for you, or a calculator on your phone, and your Eureka Math Workbook. Okay, so let's get started. Today our objective is we can compute unit rates associated with ratios of quantities measured in different units. Basically what that means is we can find equivalent ratios measured in different units. So one ratio, simplifying it or enlarging it to another ratio that would be equivalent, okay? Our first one in your workbook, it says that you're going to pass out work papers and then time yourself, but you guys aren't in class. So what we did was we kind of modified this example for you, and we made it to where it's Mrs. Jones that is already passed out papers in her classroom. So Mrs. Jones wanted to see how fast her class could pass out a stack of papers. She recorded the data in the table below and wanted to find the unit rate for each trial and to see if the resulting ratios are equivalent. So what we're going to have right here is we have our first trial. We have 24 papers passed in 12 seconds. Our first column says that we need to find the ratio of number of papers passed to the time. Now remember, we are being asked papers per my seconds of time, papers per second. Now, I always tell my students every time we're asked papers per second or anything per another measurement, what we're going to do is we see that word per and we're going to slash through it. That creates our fraction or our ratio. That tells me that my papers is going to be on the top of my fraction or ratio or the numerator of my fraction, and my seconds are going to be my denominator or the bottom part of my fraction or ratio. So for trial number 1, we have 24 papers passed in 12 seconds. So that ratio is going to be 24 to 12. And again, we're wanting to know what that rate is in order to find the unit rate. So that gives me 24 papers in 12 seconds. And how I'm going to solve that is I'm going to just simplify that fraction, or I'm going to divide that fraction out. So 24 divided by 12 gives me 2 papers per second. So that gives me 2 papers per second there. All right. So on my next trial, let's change our color for our pencil. We're going to make it blue this time. So for our next trial, we have the same 24 papers being passed out, but this time they did it in 11 seconds. So again, our first column has our 24 to 11 ratio that we have to write down. This time they did it in 11 seconds, so we're making sure that we change our 11, making that 12 a new 11 in our ratio. And then now our rates, we have 24 papers divided by that 11 seconds. So when we go in, we need to use our calculators now. We're going to take 24 divided by the 11 seconds. Give you a few seconds to complete that. So in your calculator, you should see that you had a long repeating decimal. It kept going on with a pattern forever and ever. It did not terminate or stop. I'm going to keep it to that hundredths place, that second decimal place for what I'm doing today. So now I can say for this trials, our second trials unit rate, we had 2.18 papers per second being passed out. So we can see that we're getting a little bit faster. Our time is going down that it takes us to pass out our papers from our first to our second trial, and we're able to pass out a little bit more papers per second. Okay, so now I want you to pause the video and you are going to do trial number 3 and number 4, filling out your ratio, your rate, and your unit rate all in your table. Please pause the video now. All right, so welcome back. I hope you've paused and then unpaused your video after you've completed your table as asked. So now we're going to check our answers. Our ratio of number of papers passed to the time in seconds for our trial number 3. That ratio would look like 24 to 10. We're dividing that out. That's 24 papers divided by 10 seconds, and that gives me 2.4 papers per second. So again, our time is going less. We're having less time spent passing out the same 24 pieces of paper, so we're getting a little bit faster every time. And then our trial 4, we had 24 papers for 8 seconds. So 24:8 for our ratio. We're taking 24 divided by 8, and that gives me 3. So in our last trial, we ended up with 3 seconds for each, or 3 papers for each second, excuse me. So when we talk about are the ratios equivalent, why or why not? We have a different unit rate every single time. We had a different ratio every single time between our trials. So I know they are not equivalent to each other because I ended up with separate unit rates for each trial. On our next slide, our class by gender. Again, we're going to be giving you information from our classes, okay? So let's make a comparison of 2 quantities that are measured in the same units by comparing the ratio of the number of boys to the number of girls in this class to the ratio for different classes. So in our class 1, I counted up off my roster, I had 13 boys and 12 girls. So my original ratio for that would look like 13 to 12. But now I need to ask myself, can I reduce 13 to 12 any simpler? Can I get it any lower than 13 to 12? I'm going to take a second and think about it. All right, now you may have realized that 13 is a prime number. So that means there is no number that can go into 13 other than 1 and 13. But 12 is not divisible with a whole number. It's not divisible by 13. So my ratio stays the same at 13 to 12. Okay, so on my second class, it turns out I had 14 boys and 10 girls. So if I'm thinking about 14 boys and 10 girls, that original ratio looks like 14 to 10. And then I need to think about, can I reduce that ratio down any further? I can reduce that ratio because 14 and 10 are both divisible by 2. So if I go to reduce that down to simplify that fraction, I end up with the fraction or the ratio of 7 to 5. And then I cannot reduce that any further. There is no other number for 7 and 5 that are prime numbers. So I have 7 to 5 as that ratio. Now I can definitely say that my class 1 and my class 2 are not equivalent ratios. They don't reduce down to be the same number or same fraction. So now we're going to look at our 7th grade. For the whole 7th grade, we're going to say that I have 140 boys and 100 girls. And I need to think about if I can reduce that down. That original ratio is going to look like 140 to 100. And if you're noticing anything from your your class number 2, this is going to be something that I can simplify or reduce down to a simpler ratio. All right, hopefully you've reduced it down. You could have gone by tens and gotten to 14 to 10, and then remembered that that's exactly what we had in our class number 2, and then reduced it down to 7 to 5, or you could have went ahead and reduced everything by 20 because of 140. 20 will go into 147 times, and then 20 will go into 105 times, and that gets me to that bottom ratio. So when I'm comparing my class number 1 to the whole 7th grade, I do not have equivalent ratios. However, when I'm comparing my class number 2 to the whole 7th grade, I do have equivalent ratios, okay? Give you a few seconds, make sure you have that written down. You can pause or rewind this video at any time. Anytime you need to come back and watch it or re-watch a certain clip of the video. All right, on my next one, how do we compare ratios when we have varying sizes of quantities? My class number 1 has 14 boys and 12 girls, so that is going to be 14 to 12 is my original ratio, and it will reduce down to 7 to 6. My next ratio, no boys to girls, is just that 7 to 6, so these two are equivalent so far. My class number 3, my boys to girls, is 16 to 12. So when I'm reducing that down, I need to think about what can I divide 16 and 12? What is the greatest common factor between 16 and 12? They are both even, so I know that 2 will go in, but that's not my greatest common factor. So if you thought of the number 4, 4 would be the greatest common factor for 16 and 12. That is correct. So when I take 4, it will go into 16 4 times, and it will go into 12 3 times. So my bottom ratio there is 4 to 3. So far, class 1 and class 2 are equivalent ratios, but class 3 kind of went out on a limb over here, okay? Then with my number of boys in class number 4, I have 10 to number of girls, which is 19. Now, 10 to 19, I do have an even number with 10, but 19 is not an even number. Can you think of any number that is divisible, whole number, that will go into 19 and come out whole again? If you said no, you're correct, because 19 is a prime number, okay? So that ratio is reduced as far down as it can get. Now, if we look at our whole 7th grade of 55 to 65, there are things that I can reduce them by. I'm going to give you about 10 seconds to think of those answers. All right, so when you reduce 55 and 65, they both can be reduced by 5s. They are both divisible by 5s. We know that because they end in 5s. So when I reduce that down, 5 will go into 55 11 times, and 5 will go into 65 13 times. Now 11 and 13 I cannot reduce any further because they are both prime numbers. There is not another number that can go into either one of those except for 1 and themselves. All right, so you have a few seconds. You can write down any 2 equivalent ratios. Please pause the video now and write down your 2 equivalent ratios. All right, so now welcome back. You wrote down your 2 equivalent ratios, which is great. On our next slide, we have which is the better by. Which is the better by? This is exercise number 1 in your book on page S.2. Value Mart is advertising a back-to-school sale on pencils. There's a pack of pencils which sells for $7.97, whereas a 12-pack of the exact same brand costs $4.77. Which is the better buy, and how do you know? So when they ask about the better buy, they want us to think about which one am I going to spend as little money as possible, okay? So when I'm thinking about that, I'm thinking about how much can I get for the lesser amount of money, all right? So in order to find that answer out, I need to divide. I need to find out how much per pencil am I actually going to be spending here. So I have my cost per pencil that I need to think about. Now, if you remember in the very beginning of the video, I told you, I tell my students, anytime I see that word per, I slash it out, and that tells me exactly what I need to know about my numerator and denominator. So now I can rewrite this fraction as my cost per pencil. So now I definitely know how much my cost is and how many pencils are in the boxes. So I know how I need to set up my fractions in order to find my unit rate or my cost per one pencil. So with my pack of 30, it sold for $7.97. That was 30 pencils. So when I divide that out, I'm going to get a long decimal. Again, I'm thinking about money, so I want to take it to the nearest penny. So let's round it up to 27 cents. It said the calculator 0.2656 repeating, with the 6 being the repeating number. So we're going to round that up to 27 cents, and then you're going to say per pencil. Now my 12 pack, I need to see how much that one is. So let's put that one back in our blue color. It's a good navy blue. Okay, our 12 pack costs $4.77. So I have my cost up top for $4.77 for my numerator, and then I have my 12 pencils as my denominator. So I need to divide that out. And you're going to get in the calculator 0.3975. Again, we want to think about in terms of money. So we want to round to that nearest penny. So that's going to end up being 40 cents per pencil, right? So again, I want to think about what exactly am I buying and how much am I actually spending per pencil. So if they're the exact same pencil, same brand, same everything, same feel, they write the same. So I have my 30 pack of pencils at 27 cents per pencil, and then I have my 12 pack is 40 cents per pencil. So I definitely don't want to spend more money than I actually have to. So the better buy here is going to be the 30 pack because it's cheaper per pencil. It's cheaper per pencil. All right, so how is finding an associated rate or an equivalent rate or the unit rate helpful when making comparisons between quantities? So we can think about this when we're talking about going to the grocery store, making sure we're staying within our grocery budget. You can start comparing, like, is it better to go to Sam's Club and buy this item in bulk? Is it going to be that much cheaper? Is it better for me to go ahead and buy the 24 rolls of toilet paper rather than the 6 rolls of toilet paper? Is it better for me cost-wise? Is it more cost-efficient for me to do it that way? Sometimes it is cheaper for you to go get the bulk, the larger quantity amount, and sometimes it's actually, when you do the math, if it's sometimes it happens to be cheaper if you're buying a smaller amount, but getting more of the packages of the smaller amount quantity. All right, in your workbook, you have some problem set problems. I want to give you guys the opportunity to work on those. You have, looks like 7 problem set problems that you need to try on your own. 7 problem set problems that you need to try on your own, and then make sure.
Mr. Fuller, your ride is waiting on you outside. Mr. Fuller, your ride is waiting on you outside. Thank you.
Sorry, guys, they were calling someone. Their ride is out front. So as you complete this work, make sure when you come to hand it back into school, you have your name on every single page. Sometimes they get unstapled or unpaper clipped. I know they've been trying to rubber band all of the work around itself when a kid turns it in, but we've got to make sure your name is on it so that we know who exactly it goes to, who to give your points and attendance to, and make sure that it gets to your correct teacher. Okay, guys? So as you come in each week, make sure you're just tearing out the pages that you've done in your workbook and turning them in for us. We would really appreciate it. And again, this is Miss Adkins. You can call, email, anytime you need to, or you can call your math teacher if you need to get a hold of them. We're always here to help. Okay, guys, this is going to be it for lesson 1. So if you need to go back and watch it again, you're more than welcome to. All right, guys, have a good one.